My name is Mishri Bhanwadia, and my topic for computer organization and architecture 3D implementation is bus arbitration by polling technique. The system bus connects CPU, memory, and input-output processors. In multiprocessor systems, many processors share the same system bus. Multiprocessors may request memory access, perform input-output operation, also access shared resources. This may lead to data conflict, data corruption, or unpredictable behavior. So, we need a system which decides which processor gets control of the system bus when multiple requests occur. So, here is bus arbiter, which is connected to the four system or the four different processors. These are three signal types: bus request signal, pole signal, and bus busy signal. Bus request is a signal sent from bus to the arbiter to indicate that one or more devices require access to the bus. In polling, bus grant is replaced by a set of poll lines. The arbiter will not say you can use the bus directly. First, it will ask, does the device with this address needs the bus? And thus bus grant or poll lines will get active when the address of the system is matched. Bus busy signal is shared line that indicates that the current system is accessing the system bus. Let's say two systems are requesting at the same time. So polling will start from 0, 1, 2, and 3. It will be matched and the bus busy will be high and the system bus grant will be given to that system. So here you can see the system 2 and system 3 are requesting. First, it will get matched to system 2 and it will be granted to system 2. And then it will again start from system 0. And then it will poll to system 1, 2, and then 2, 3. So every time if the multiple processor are requesting the system bus, the polling starts from 0. This is the inside of bus arbiter. This is the clock, the counter, decoder, control logic, priority rotation, bus request monitor, status monitor, and registers. And this will program the priority type. The counter is the primary component for tracking the polling sequence. It generates repeating binary index to decide which specific system is polled next. Then the decoder takes the binary output from the counter and converts it into active signals on individual poll lines. For example, a counter output is 10 that will activate the poll line of system 2. In fixed order polling, system 0 always had the highest priority. If S0 constantly requests the bus, the lower priority systems like S3 may never get a turn. Round robin, the arbiter ensures that each system gets an equal chance by rotating the starting point. After a system finishes its turn, the arbiter does not reset to 0. Instead, it uses priority rotation logic to start the next poll from system immediately following the one that just finished. So the rotation goes like this. In cycle 1, arbiter polls from S0, S1, S2, S3. The next poll then starts from S2 and not from S0 as in fixed polling. The new order is now S2, S3, S0, S1. Here polling starts from S0, S1. S1 is granted the system. Now the pointer is moving to S2. S2 is granted the system and now the pointer sweeps to S3. In polling technique, address mapping is the process of translating binary value generated by arbiter into specific signal that identifies unique system on the bus. Firstly, the counter generates binary address. This binary value is sent to the decoder, which maps the bits to one specific pole line. The internal matching. Each system uses internal matching logic to compare its value hardwired system ID against the broadcast pole line address. When mapped address matches system's ID and that system has a pending request, it recognizes an implicit grant and takes the control of the bus. Because this mapping is stored in programmable priority register, the sequence of which address is mapped to which priority level can be changed via software. The advantages of this system is priority is determined by polling order, which can be changed dynamically via software using programmable priority registers. The disadvantages are sequential checking delay. Because the arbiter must scan through addresses one by one, there is inherent delay that increases as more devices are added to the system. Thank you.